Welcome to Chapter 4. Good to see everybody. All right, in Chapter 4, we're going to introduce a concept called the position vector. Now, last year, if you remember right, a position is always given by the letter X. Sign out of here. All right, if we look through, we're going to change that because the position in the X direction is kind of confining. So if we start to look at movements that are not on the x-axis, or even on the y-axis, or even on the z-axis, we can actually find out where we're located relative to some point using a position vector. So I just happen to draw one right here on the board. So if you notice now, position now is given by the letter R, and we're going to put a little arrow above the top just to let everybody know that it's actually a vector. So I have my position vector here, and if we note, let me draw some components for you. I want to simplify the components a little bit. Last time we've been using AX and the I, and then we've been using AY and the J. I think I'm just going to use one variable for the component, the magnitude of the component. So here I'm just going to say X in the I direction. And then of course here, this is going to end up being Y. And of course it's upward, so we have in the J direction. Don't forget to put the little hats on, and I always forget to put the little dot above the I and the J, but don't you do that. Okay, now, I'm looking here, I'd like to actually write this out in terms of this unit vector notation. So what is R equal to? R is equal to X in the I plus Y in the J. All right, now what happens if the vector here is projected, say, outward from the board? So if we were to take this, and this vector actually could be tipped out in the K direction, actually, instead of being flat to the board, but actually projecting out into space. You know, just like anything else in the world, I mean, things don't have to be along the x-axis or the y-axis. You know, we could actually be standing in the middle of this room at some location, even off the floor. So we need a K. So what we would end up doing there is just putting Z in the K direction, something like that. So this is a nice unit vector version of the position vector itself. All right. Our next thought is we would like to find the displacement vector. So what we're going to do now is, last year we would say displacement is the change in X. Gone. All right, fine. Displacement now is actually going to be given by the change in R, the change in the position vector, and that'll tell us how far we've actually gone. So let's write this out. So we know that the displacement vector is going to be two vectors. We need a vector R2 and a vector R1. Let's say this is our final position, and then this is our original position. So we need to have a minimum of two vectors.